Hello guys, welcome to our channel. In this video we are going to see about the short notes and also the formulas for the first chapter of chemistry, some basic concepts. It will be useful for your quick revision for competitive exams. First topic is the type of measurements. First type is precise and second one is accurate. How to find whether a measurement is precise or accurate means precise means the value will be close to the true value. Accurate means it is very close, it is near to the true value. What is the definition of precise? Means closeness of the value to the true value. Accurate means agreement of the particular value which we have found out to the true value. Next, for finding out the number of significant figures, a certain rules was followed. And I am giving you with examples. First one, all non-zero constants are significant. Like in 1.75, all three non-zero constants are significant and number of significant figures are 3. Next, 0.015, it has only two significant figures. This 0 is insignificant. All the zeros to the right of decimal point and also the right of non-zero constant are significant. It is only to the right of decimal point and not to the non-zero constant. So here only two significant figures. In this number 62.017, it has 5 significant figures. This 0 is significant because it is present after the decimal point and also after the non-zero constants in this one. And also the zeros which are in between two non-zero constants are significant. This example you see 5.208, it has 4 significant figures. The 0 which are present in between two non-zero constants are significant and it has 4 significant figures. If they have given only a number, means without any decimal point, you should take this significant figures as infinity. For 8 it is infinity significant figures. If they have given any meter, if the number is without decimal point also, if they have given some meter or else some unit, means you should take the number of significant figure as 1, or else if they give 14 means 2 and etc. And the powers of 10, all the powers of 10 are insignificant. For example 8.701 into 10 power 5. These 4 numbers are significant and the power of 10 is insignificant. So it has only 4 significant figures. Rounding off. It has 3 types. The first rule is if the number is greater than 5, the preceding number should be added with 1. For example 2.317. The last number is greater than 5. So the preceding number should be added with 1 and it becomes 2.32. If it is less than 5, last number is less than 5, the preceding number should be left as it is. For example, the same one, 2.314, means it is less than 5. So the preceding number should be unchanged. If here it means here it is 1, means the result should also contain 1 and it should not be added with 1. If the last number is equal to 5, there are 2 types. If preceding number is even or preceding number is odd. If the preceding number is even, the preceding number should be left unchanged. If the preceding number is odd, you should add 1 with the preceding number. For example, here you see last number is 5 and the preceding number is 2, which is even. This 5 is only taken out and the 2 is left unchanged. Then the preceding number is odd, means the preceding number should be added with 1. For example 2.315, it will be converted to 2.32 because the preceding number is odd, which is 1. It should be added with 1 and it becomes 2.32. Next, they have many applications in addition, subtraction, multiplication and division. The rules for significant figures and also rounding off. Addition or subtraction means if they have given likewise 5.16 plus 3.2, if you had, you will get 8.36. You should round off these figures to a particular value. In case of addition or subtraction means the result should contain the small number of decimal in both the numbers, which is containing less number of decimal point, means this one, because after the decimal point there is only one number and the result should also be similar with the number. So I have rounded it off to 8.4. Why I have added plus 1 here? The last number is 6, which is greater than 5. So preceding number should be added with 1. If multiplication or division means, I have given an example like 1.6 into 5.02. You will get 8.032. In multiplication or division, the result should contain the small number of significant figures as in the question. Like this one has 2 significant figures, it has 3 significant figures. So the result should contain only 2 significant figures. And I have rounded it off to 8.0, which contains 2 significant figures. Here it has it is significant. The 0 is significant because it is to the right of decimal point and also to the right of non-zero constant. Then laws of chemical combination. First law is law of conservation of mass. It states that the total product mass after the reaction is equal to total reactant mass. That is, matter is neither created nor destroyed. For example, calcium carbonate. If you have taken 1 mole, it contains 100 grams of calcium carbonate. It undergoes decomposition while heating and produces calcium oxide plus carbon dioxide. For 1 mole of calcium oxide, it contains 56 grams of calcium oxide. Carbon dioxide means 44 grams. If you add up both of these, you will get 100 grams. So which is equal to reactant mass. So the condition is applied here. And it is very important, it is not applicable for nuclear reactions. Why it is not applicable means some of the mass gets converted into energy there. So it is not applicable to nuclear reactions. Law of constant or definite or fixed proportion. You take an example. First, the definition is, if a compound, it states that in a compound, same elements are present in a fixed proportion. I have taken 2 compounds. It has calcium, carbon, oxygen as their constituents. In a compound, same elements are present in a fixed proportion by their weight, irrespective of any factor. If I have taken 1 mole of calcium carbonate in 1 petri dish and also another petri dish contains calcium carbonate likewise, both the petri dish have same mass of calcium, carbon and oxygen as their constituent mass, irrespective of any factor you can change. It contains, if compound 1 has 40 grams of calcium, 12 grams of carbon and 48 grams of oxygen, the second compound also have 40 gram, 12 gram and 48 gram respectively. And it does not change with respect to change in any external conditions or anything. Then law of multiple proportion. What is law of multiple proportion means? It states that if two elements form 2 or more compounds in which the weight of an element combining with the fixed mass of other bears a simple whole number ratio. Means it bearing a simple whole number ratio. Here I have taken carbon monoxide and carbon dioxide. Both the elements, the constituent elements are carbon and oxide in both the cases. Here oxygen, 12 gram of carbon is combining with 16 gram of oxygen. Here 12 gram of carbon is combining with 32 grams of oxygen. And the weight of oxygen, which is forming compound with carbon, have a simple whole number ratio like 16:32, which is 1:2. This is the simple whole number ratio. Then Gay-Lussac's law. It is applicable only for gases. It states that when gases combine or produce in a chemical reaction, they do so in a simple ratio by volume provided all gases are at STP. If I have taken the production of ammonia, N2 plus 3H2 gives rise to 2NH3. What is the stoichiometric ratio? 1 mole, 3 mole, 2 mole. And the same stoichiometric ratio will contain as the volume, 1 volume, 3 volume and 2 volume. Then Avogadro law. Avogadro law states that equal volume of all gases at STP have equal number of molecules. Here molecules, it is very important. It's not like atoms or moles or anything. Here it is molecule. Then Dalton atomic theory. What he has said, like atom is an indivisible particle. Matter is made up of atoms, which is indivisible. Atoms of a given element are identical, that is, they have similar physical and chemical properties. Same physical and chemical properties. Atoms of different element have different chemical or physical properties. Then atoms of different elements combine with each other in a fixed, simple whole number ratio of the compounds. Atoms can neither be created nor be destroyed. Here, Dalton's atomic theory can explain all laws of chemical combination. Then we are going to see about the formulas. 1 AMU equal to 1 by 12 the mass of carbon 12 isotope, and it is equal to 1.6605 into 10 power minus 24 grams, which is the inverse of Avogadro number. Avogadro number, you know, Na is equal to 6.6 into 10 power 23. Then average atomic mass means A bar equal to, they will give you two things. They will give two isotopes, and they will give their percentage abundance in the Earth's crust. You have to apply the formula for finding out average atomic mass, which is atomic mass of the first compound into percentage abundance of the first compound plus atomic mass of second compound into percentage abundance of second compound divided by 100. They will also ask for the average molecular mass and also the average ionic mass. So the same formula is applicable for all the cases. Next one, atomicity. What is meant by atomicity means the number of atoms present in a compound. It is called atomicity. For monoatomic elements, you see helium, neon, argon, krypton, xenon, radon, all inert gases, noble gases, or monoatomic. Here it has atomicity 1. And H2, N2, O2 all are diatomic, atomicity 2. And triatomic means N3, I3, BF3 all are triatomic. Sorry, BF3 won't come. Sorry, N3, I3 have atomicity 3. Number of moles, this is the fundamental formula. Number of moles equal to number of molecules by Avogadro number equal to weight of the compound divided by gram molecular weight of the compound. If it is gas, you can apply this. Volume of the gas divided by 22.4 liters. Or else if you have taken ml over here, you should change this number as 22,400 ml or centimeter cube. Gram molecular weight, they will give you vapor density in most of the cases in finding out empirical formula. In finding out empirical formula, they will give you vapor density, and you should convert into gram molecular weight. So you should apply this formula there. It is only applicable for gases, and gases only have vapor density, so it is only applicable for gases. Gram molecular weight equal to 2 into vapor density. Then they will give a compound, and they will say to find out the percentage weight of a particular element in that compound. So you have to apply this formula, means percentage weight of element by total compound weight equal to gram molecular weight of the element into its atomicity divided by weight of the total compound into 100. For example, they will say you to find out the percentage weight of hydrogen in sulfuric acid H2SO4 likewise. Then percentage purity. Percentage purity means they are if you want to find out this compound from its impure sample, so you have to apply this formula, percentage purity. Weight of the compound, you should write the weight of the compound here divided by the weight of impure sample into 100. Percentage yield or percentage completion of a reaction means number of moles or weight or volume of a product formed divided by number of moles or weight or volume of the product to be formed into 100. First, if a compound is it should produce 100 grams of the product, and in the middle of the reaction we are seeing means it is producing only 25 grams of the product. So remaining 75 should be less, it should form after that. So what is the percentage yield means how much it is formed now, 25 grams it is formed. So total how much should be formed, 100. So 25 by 100 into 100 means 25%. So the percentage yield of the reaction is 25%. So that you should find likewise. Limiting reagent. What is meant by limiting reagent? Limiting reagent is the reactant and it is not the product. It is a reactant which is taken in less amount and it is completely consumed in that reaction. And it is very useful to find out how much the product is formed or else how much excessive reactant left. We can easily find out with this. And limiting reagent. Limiting reagent we could not find with the help of decomposition reaction, or else something which is involving only one reactant. For limiting reagent we should have at least two reactants as there. So we can take a comparative stoichiometric ratio or limiting reagent foundation. For limiting reagent identifying, you should write the number of moles given in the question divided by the stoichiometric coefficient in the balanced equation. And also for gases means they will give you volume of the gas divided by stoichiometric coefficient in the balanced equation. For writing general formula for hydrocarbon oxidation reaction, you should follow this. CxHy plus x plus y by 4 moles of oxygen gives rise to only x carbon is here. So total CO2 will become xCO2 plus y by 2 H2O. CxHyOZ plus x plus y by 4 minus z by 2 moles of oxygen, and x, same thing, x carbons are there, so xCO2 will produce plus y by 2 H2O. Later they will say you to find out the strength of the solution. Strength of the solution formula is weight of solute in grams divided by volume of solution in liters, gives rise to gram liter inverse. This is the unit of strength. They will ask you to find out percentage weight by weight. Percentage weight by weight means weight of the solute divided by weight of solution into 100. It has no unit. And weight of solution is equal to weight of solute plus weight of solvent into 100. Likewise, you can find for percentage volume by volume, means volume of solute by volume of solution into 100, and it also has no units. And volume of solution is equal to volume of solute plus volume of solvent you can have. Then combinedly they can ask percentage weight by volume, means weight of solute in grams divided by volume of solution in ml into 100. It has unit like gram per ml. So you can also write the formula as weight of solute divided by weight of solution into density of the solution into 100. Or else you can combine these two and can write percentage weight by weight into density of the solution. Parts per million equal to weight of solute by weight of solution into 10 power 6. If you split this into 10 square and 10 power 4, you can write it as percentage weight by weight, this total term, and into 10 power 4. Molarity. Molarity equal to number of moles of solute by volume of solution in liters. And it has units like mole liter inverse or mole per liter. Molarity means weight of solution divided by gram molecular weight of solute. Weight of solute divided by gram molecular weight of solute into 1000 divided by volume of the solution. It should be in ml because we have changed this, so we should multiply it with 1000. Next one. The other formulas are percentage weight by volume into 10 by gram molecular weight. And we can also include this term by multiplying the density. Percentage weight by weight into 10 into density of the solution divided by gram molecular weight. Here they can give in a question like specific gravity, which means density only. You should know that specific gravity means density only. Molarity equal to strength divided by gram molecular weight of the solution. Upon dilution, what will become the molarity? The number of moles are same only. Initially, what is the number of moles? We are adding only the solvent, not the solute. Hence, the number of solute in the initial and the final state will be equal. So, molarity initial into volume initial equal to molarity final equal to volume final. Volume of solvent added means delta V, which is equal to final volume minus initial volume. If you add two or more solution, what is the resultant molarity upon mixing of two solution? Means M1V1 plus M2V2 divided by V1 plus V2. For acids, the resultant molarity will become MH plus. Base means resultant molarity means molarity of hydroxyl ions. For if we are adding acid and base, what will be the resultant molarity? Means it depends upon the molarity of acid and also the base. If acid is greater than base, the resultant molarity becomes the molarity of hydrogen ions. Like the formula will also change, like here minus you should put MaVa minus MbVb divided by Va plus Vb. If base is more, resultant molarity will become the molarity of hydroxyl ions. Molarity of base Vb minus MaVa divided by Va plus Vb. If both the molarities are equal, they form salt solution, and you can apply this formula. Molality. Molality means number of solute moles, number of moles of solute divided by weight of the solvent in kilograms. It has a unit like mole per kilogram. What are the other formulas for molality? Means weight of solute by gram molecular weight of solute into 1000 by weight of solution. It should be in grams because we have converted it from kg to grams. We are multiplying by 100. This is very important formula. They will give molarity, density, and they will give compound H2SO4, FeSO4, something they will give, and you want to find out the gram molecular weight of solute, apply. In this formula they ask for molarity. This is from this formula they can ask you direct questions. Only applying the values is required. This formula is very important in exam. Then molality. What are the other formulas? Means molality equal to percentage weight by weight divided by gram molecular weight of solute into 1000 divided by 100 minus percentage weight by weight. This is also an important formula. Then upon dilution, what will become the resultant molality? Upon dilution, we are adding only the solvent, and initial and final solute concentration are same. Like Ni equal to Nf. Number of moles of solute is similar only. So MiWi equal to molality final weight final. So resultant molarity means M1W1 plus M2W2 divided by W1 plus W2. Then mole fraction. It is represented by chi. I am taking two solute and a solvent. It is solute and a solvent. Solute mole fraction is chi A. Solvent is chi B. I can write it as what is the definition for mole fraction? Means it is the number of moles of solute divided by total number of moles of the solution. It is equal to Na by Na plus Nb. Chi B means Nb by Na plus Nb. So if you add both the mole fraction, you will get 1. They also ask the percentage mole percent means chi into 100. The relation between molality and mole fraction is molarity equal to mole fraction of solute by mole fraction of solvent into 1000 by gram molecular weight of the solvent. Gram equivalent weight means gram molecular weight divided by n factor. Example, they will standardly give some example which you can apply in the question. They have standardly taken, which is hydrogen, oxygen and chlorine. The equivalent weight becomes, its weight is gram molecular weight is 2 and n factor is 2. So it is 1 gram. Its weight is, oxygen weight is 16 divided by 2. N factor 2. So it is 8 gram. Chlorine 35.5 grams divided by 1 will give 35.5. Normality means equivalent of the solute divided by volume of the solution in liters. Equivalent equal to weight divided by gram equivalent weight, and also equivalent equal to number of moles into n factor. Since gram, if you apply for gram equivalent weight equal to gram molecular weight by number of moles. Gram equivalent weight divided by n factor. So you can get number of moles into n factor. If they are asking for milli equivalence, means you should take this one in millimoles into 10 power 3 into number of n factor. It is millimole. It should be in millimole, n factor into 10 power 3. Apply in normality formula. Milli equivalence equal to N into V. V means volume, which is taken as milliliter. Normally it should be in liter. If you are finding out for milli equivalence, it should be in milliliters. Normality formula is weight of solute divided by gram molecular weight of solute into 1000 divided by volume of solution. It should be ml because we have multiplied 1000. Other formulas are percentage weight by volume into 10 into gram equivalent weight. Then percentage weight by weight into 10 into density divided by gram equivalent weight. What is the normality? Other formula is strength divided by gram equivalent weight, which is similar to molarity formula. It has strength divided by gram molecular weight. Here gram equivalent weight. So what is the relation between normality and molarity? Means normality equal to n factor into molarity. Dilution. Upon dilution, what will happen? The equivalence will become the same. So NiVi equal to N of Vf. If they are asking for resultant normality, if they mix two solutions, it will become N1 V1 plus N2 V2 divided by V1 plus V2. What is the law of equivalence? Means equivalence of one reactant equal to equivalence of another reactant. So it will become N1 V1 equal to N2 V2. If the volumes are same, similar volume of the reactant taken means normality of both the reactant will become equal, and you apply for the formula. They will give you three of the terms. Terms, and you have to find out another one. So this equation becomes useful. Then hydrogen peroxide. Hydrogen peroxide is highly unstable and it decomposes to water and also half mole of oxygen. If in question they will give you like 10 volume of hydrogen peroxide, means 1 ml of hydrogen peroxide gives rise to 10 ml of oxygen which is available. So it is called available oxygen. 10 ml of oxygen is available oxygen. In questions likewise they will give 10 volume of 1 liter hydrogen peroxide. They will tell you to find out the weight or molarity, normality, percentage weight by weight, etc. So you take this equation. Hydrogen peroxide gives rise to H2O plus half O2. And stoichiometric moles is 1, here half. 1 mole of hydrogen peroxide has 34 gram, here 18 gram, here 22. It is a gas. So it should be 22.4 divided by 2, half mole, no. So it will give 11.2 liters. Weight of hydrogen peroxide they will ask you to find out. It will become 34 by 11.2. It will give this answer 30.36. If you want to find out percentage weight by volume, what is the weight? We have find out 30.36. What is volume? It is 10 volume. 10 volume into 100. It is 10 times. What is percentage weight by weight? You will find like 3.036%, and they will give for 20, 30 and also 100. So multiply this number with 2, 3 etc. to 10. You will find out the percentage weight by weight. Then molarity. Molarity means volume strength. What is the volume strength? 10 volume strength they will give, and divided by 11.2. If normality means its n factor is 2. If you multiply by 2, it will cancel out and give 5.6. And volume strength, normality equal to volume strength divided by 5.6. So only empirical formula is left out. I will cover you in next video. And n factor, how to find out n factor, I will give you another video. So this is the end of the chapter, and I will give 2 videos separately for empirical formula and finding out n factors. Until then, keep watching. Thanks for watching this video. If you really like this video, hit the like button, share with your friends and subscribe our channel. Thank you and bye.